Hello, this is the lesson for section 1.8, solving linear and absolute value inequalities. I'm going to break this into two videos. So first, we will talk about what is an inequality. So an inequality is two expressions set to less than, greater than, less than or equal to, greater than or equal to, or technically the not equal to is an inequality to each other. But we solve the not equal to exactly like we solve the equal sign. It's these that sometimes they have some extra considerations. So we still want an inequality, you still want to solve to find out what x is. But this time x is going to be a range of values and not just one value. So we're going to use interval notation, and I have a separate video that goes over interval notation. That's how we're going to express our answers. One important note, less than, greater than, less than or equal to, and greater than or equal to are not symmetric. So our expressions can't switch sides unless we also change the inequality sign as well. So what that means is that for equal sign, if I say x equals 4 and you say 4 equals x, we're both right because the equal sign is symmetrical. But if I say x is less than 4 and you say 4 is less than x, that's wrong. So you have to switch this sign. If these numbers switch side, you also have to switch the sign. So x is less than 4 is equivalent to saying 4 is greater than x. And so that gets people who don't show their work very much. If you lose sight of what side the x is, then you might run into a problem where you aren't considering which way the inequality sign should go. So here we go with solving linear inequalities. We also remember this rule. This is one of the things that is different about solving with inequalities. When we multiply or divide by a negative number, we must switch the inequality signs. So for example, let's say we have 3 is less than 4. And that's true because on a number line, 3 is to the left of 4. Well, if I take and use the golden rule of algebra and I multiply both sides by -1, I would get -3 and -4. And if I don't switch the sign, see, that's not true, right? Because -4 is to the left of -3. So when you multiply by -1, it's like you move these +3 to the left side of 0, move that +4 to the left side of 0. And so you have to switch the signs. So when you multiply or divide, because division is just multiplying by the reciprocal, they are inverse operations. When you multiply or divide by a negative number, you have to remember to switch the signs. Okay, so let's talk about interval notation. It's a way of expressing a group of answers, and it's a shorthand way of expressing a number line solution. So x is greater than 2 would look like this on a number line. So x is greater than 2 means that it can't equal 2. That wouldn't give you a true statement. But any number to the right of 2 would give you a true statement. So that's what x is greater than 2 looks like on a number line. So using interval notation would look like this. If we are not going to include the number, we use a parentheses. So all the numbers 2 to infinity. We have to put the 2 there because what that does is it tells us that 2 is an open boundary. And that tells us that 2.0000001 is part of the solution, but 2 is not. So you can't start at 3. You have to start at 2, but the parentheses mean that you don't include the 2. All right, the second one, x is between 3 and 5, where you don't include 3 and you do include 5. 3 is less than x, and x is less than or equal to 5. So x is between 3 and 5 looks like this on a number line. So you have your 3, you have your 5, open circle on 3, closed circle on 5, and all the numbers between 3 and 5 are in the solution. So in interval notation, you would have parentheses 3 because it's an open boundary, and a comma, and then 5 is the end of the interval notation. Now in this case, we're including the 5, so that would be a bracket. So the parentheses don't include the number, it's just an open boundary. The brackets mean you include that 5, that's a closed boundary. Okay, here's a third one. X is not equal to 5 looks like this on a number line. Okay, now we've done x is not equal to 5. We've just been happy with this, but now we're going to look at the number line representation. What that's saying is there's a hole, an open circle at 5, and every number to the left of 5 isn't 5, and every number to the right of 5 isn't 5. So that's a whole lot of things that are not 5. So in interval notation, you always remember interval notation is a shorthand way of writing a number line. So you start from left to right. It has to always be left to right. It follows the way a number line does. So what happens here is that this means it goes on forever and ever towards negative infinity. So you would put parentheses negative infinity, parentheses because you can't include or contain negative infinity. And then 5 is an open boundary. And then you use a union symbol. And then you pick up at 5 again. And then on the right side, it goes to infinity. So that's what x is not equal to 5 looks like using interval notation. Okay, so now we're ready to do some examples where we solve some linear inequalities, and you solve these just like you solve equations, except when you multiply or divide by a number, you have to switch the inequality and you have to keep track of where x is. So writing equivalent inequalities is going to be important. So we're going to add 16 to both sides, and we're going to write 2x is less than or equal to 25. You have to keep track of this. Then we're going to divide by 2, and now x is less than or equal to 25 over 2. But in this class, we do not use set builder notation, which is what this is called. We use interval notation. So until you get good at it, you might want to graph. 25 over 2 is 12.5. We'll put 25 over 2. And all the numbers that equal to means we get to include the 25 over 2, and all the numbers to the left of 25 over 2 are less than 25 over 2. So the solution, you don't write x or anything, you just say, okay, the solution is, remember you read left to right, negative infinity, comma, 25 over 2 bracket. That is your solution. We write the solutions in interval notation. Okay, here's one where I put x on the right side of the inequality. So you have to keep track. You can't just move it to the left because the inequality signs are not symmetrical like the equal sign. So we're going to subtract 8, and you have to put negative 4 on the left is greater than negative 3x. Don't switch the sides until we're done. Now we're going to divide by negative 3. You have to be very careful, pay attention to detail. We're dividing by negative 3 because we want that to be 1. Okay, and a negative 4 divided by negative 3 is 4/3. Okay, so negative, you got to know your sign rules. Then you have to remember, oh, I divided by a negative number. So you have to switch the inequality sign. Don't switch the side of the x, just switch the inequality so that greater than is going to become a less than, and you have x. Okay, now that you have solved for x, now you want to put it in the right direction so you don't mess up. So if you put x over on the left, from the right to the left, then you get the open, you might have heard in middle school, the open alligator mouth is pointing to the x. Well, you have to keep it pointing to the x. So 4/3 is less than x is the same as x is greater than 4/3. So interval notation, let's draw a number line first so we get the hang of it. That would be an open circle on 4/3, and all the numbers greater than 4/3 is to the right. So this solution would be parentheses 4/3 to infinity. That's how we write the answer. So just draw the number line until you get the hang of it. Okay, here we have a negative. You can put the understood 1 if you want. That's negative 1/2 x. You can think of it that way if you want, or you can just say, well, let me add 6 to both sides. Okay, that's going to give me negative 1/2 x is less than 1. Then remember, you can multiply by the reciprocal, so the reciprocal of negative 1/2 is negative 2. So we multiply both sides by negative 2, and remember, when you multiply by a negative number, it's going to switch the sign. So that would be parentheses negative 2 to infinity. Okay. All right, next one, let's add 6. So that's 2/3 p is less than 24. And then to get rid of 2/3 times p, we can multiply by the reciprocal. And at any time you can pick up the calculator. This 3 divides out, this 2 divides out p. We didn't multiply or divide by negative, so it stays less than. I'm going to cross cancel here. You can use your calculator, but 12 goes into 2, 2 goes into 2 once, and 2 goes into 24 12 times. 12 times 3 is 36. So if we draw a number line, that's all the numbers to the left of 36. So this would be negative infinity. Got to read left to right to 36 with a parentheses. Okay, that's really the only new thing, but on the back of the notes page, I've given you some more complicated inequalities. They have variables on either side. So you remember you solve that just like you would an equation. So if you feel ready to try that, you can, or you can watch me. But pause the video if you want to try it. If not, I'm going to keep going. Okay, so this one, we have 5x minus 6 is greater than or equal to 9x plus 3. So remember, we want to get our terms on the same side. Now you could move this 5x over here, which is good news. You'd have a positive 4x, and you won't have to divide by a negative. Or you could move this 9x over here, which would give you a negative 4x, but the good news is you would have x on the left. So you have to decide, which way you like it. I'm going to move my 9x to the left and get negative 4x minus 6 is greater than or equal to 3. Then I'm going to add 6 and get negative 4x is greater than or equal to 9. Then I'm going to divide by a negative number. So when I divide by a negative number, it's going to switch the inequality. 9 over negative 4 is the same as negative 9/4. Okay, do you remember how to graph that, write that in interval notation? That's going to be negative 9/4 included, and then all the numbers to the left of negative 9/4. So did you remember you have to read interval notation just like you were looking at a number line from left to right? So it's negative infinity to negative 9/4 with a bracket. Number 6, we have something we have to distribute here. Remember, we can't add those two together for 2 reasons. They aren't like terms, and you have to multiply before we add. So I'm going to go ahead and distribute this 8 and then add like terms. And now it's time to decide what we want to do. Again, if you move this term over, there's no terms left on the left. You'd have to put a placeholder of 0. So I'm definitely going to move this 13x over here. And that would give me negative 9x is greater than negative 24. Divide by negative 9, and that means we have to switch the inequality when we divide by a negative number. Then we have to know our sign rules. So there's a lot to forget about here. You just have to be careful. Negative divided by negative is positive. And then 24/9. 3 goes into both of those, so I've got to reduce this. And I do count off if you don't reduce. So this is actually x is less than 8/3, which is negative infinity to 8/3 with parentheses. You will be asked to write it in integral notation, so don't forget that. All right, if you feel ready now, pause the video. Try the last two. Okay, so I'm going to go ahead and distribute and add like terms on each side. So this would be 6 minus 3x is less than or equal to negative 30 minus 15x plus 7. So we have 6 minus 3x is less than or equal to negative 30 plus 7 is negative 23 minus 15x. Okay, I'm going to move this minus 15 over to this minus 3x by adding 15x to both sides. So that's 6 plus 12x is less than or equal to negative 23. I'm going to subtract 6. Do you change the sign? No, you do not. You don't change the sign when you're subtracting. You change the sign when you're multiplying or dividing by a negative number. Okay, so that gives me negative 29. I'm going to divide by a positive 12, so we do not need to change the sign. Nothing goes into negative 29 over 12, so this in integral notation would be negative infinity to negative 29 over 12 bracket. Okay, so that's how you solve linear inequalities, and that's how you use interval notation.